to keep in mind, when we talked about trig functions earlier in the semester, I told you that anything we do with them requires our trig functions to be in radian form. So that is still true. So we will always have to be in radians before we can do a derivative. So if I just give it to you in a problem, we would assume that it's radians. If I told you degrees, you would have to convert it. So remember, if you need to convert 180 degrees is equal to what? Pi. 1 pi. Because all the way around the circle is 360, which is 2 pi. So 180 is equal to pi. So common ones, 30 degrees is what in radians? Pi divided by 6. 45 degrees is pi over 4. Think about just dividing them by 180. 60 degrees. 90 degrees. Okay, so those are the common ones that come up. We know that our trig functions, if you find a number in the domain that's continuous there, we do know that certain ones have asymptotes that come up, like tangent, cotangent, secant, cosecant. So they're not necessarily continuous everywhere, but if it is in the domain, then it's continuous there. Some other things that we will be using here. Sine squared theta plus cosine squared theta equals 1. And the sine sum formula will come in handy at times. So sine of x plus h is sine of x cosine of h plus cosine of x sine of h. So this is just kind of a recap of some pieces of that trig part that we will need. One result that we had way back in chapter 2, limit as theta approaches 0 of sine theta over theta does equal 1. So that's something that we've seen before, but we'll come back up here. All right, let's do a problem. So if I want to find the limit as theta approaches 0 of cosine theta minus 1 over theta, can I just plug in 0 here? No, we can only plug it in if it's defined. We can't divide by 0. So when we did these, a trick that we used a lot was multiplying by the conjugate. So if I multiply by cosine theta plus 1 on top and bottom, so if we FOIL, we get cosine squared theta plus cosine and minus cosine cancel, minus 1 over theta times cosine theta plus 1. Cosine squared theta minus 1. Is that at all familiar? It's really close to this formula. If you have cosine theta minus 1, what would that be equal to? Almost.
Negative?
Negative sign, right? If you subtract it over, sine squared is 1 minus cosine squared. So cosine squared minus 1 would be a negative sine squared. Okay, remember when we did these limits, a lot of times we would kind of break things apart. So a negative sine squared, that's like a negative sine times the sine. I'm going to put the theta under one of these and the cosine theta plus 1 under the other. So I didn't change my problem, I just rewrote it a little bit. Then, as theta approaches 0, what does sine theta over theta turn into? 1. That's the thing that we were able to accept as fact before. And this, we could evaluate. Sine of 0 is 0, cosine of 0 is 1. So I get 0 times 1, which is 0. So this is the second thing that it can be useful to us. So it's kind of going back a little bit to these limits, but we need limits in calculating derivatives. That's where they come from. So far, so good. So let's take a look of sine. We'll look at the graph of sine and then we'll draw its derivative. So if we were going to graph sine, we go from 0 to 2 pi. So sine starts at 0 and then goes up. Something like this. Okay. If you were going to draw this derivative, we know that right here the tangent line would be horizontal, so the tangent would be 0. Where else is the derivative going to be 0? 3 pi over 2. This part of the graph was increasing. That means the derivative has to be positive. Then, should be more like this. Okay, then it's decreasing. So that tells me my derivative is negative. I need to make my lines a little better. So we're going to be negative, but we've got to come back here is when we have to be 0. So it's decreasing this whole time, so it has to be negative. And then after 3 pi over 2, it starts increasing again, so it should be positive again. Okay, so what does this look like, that blue one? Does it look like any graph you're familiar with? The other one? Cosine, yeah. So we kind of believe that the derivative of sine might be cosine. Let's use the definition of a derivative to see if that's correct. So the definition of derivative is the limit as h approaches 0, f of x plus h, so that would be the sine of x plus h, minus f of x, so that's the sine of x, all over h. We can't just plug in our h here because we're getting 0 on the bottom. But I had you write down the formula for sine of x plus h just a little bit ago. That's sine of the first, cosine of the second, plus cosine of the first, sine of the second. So let's try to maybe regroup a little bit. Both of of these have a sine x in them. So I'm going to put those two terms together. Plus, and then I'm just going to pull this other term off to the side. Okay, I haven't changed my problem. If I put this back together, I still get the same fraction. In this first one, what could you pull out of there? Mm-hmm. They're really close, guys. We have a sine x. From our theorem, cosine h minus 1 over h. What is the limit of that as h approaches 0?
0.
Yeah.
So one we worked out before, so that's a 0.
I do know.
Plus cosine x times, what's the limit as h approaches 0 of sine h over h? 1. And we get 0 plus cosine x, which is cosine x. So that means the derivative of sine is cosine. I proved it for you. You will not have to do that on your own. I just wanted to show you where it came from. So now you can take this for granted. From now on, you need to know that the derivative of sine is cosine. So let's work out a problem involving that. If I asked you to find the derivative of x squared sine of x, what will you have to do here? Product rule. We have x squared times the sine of x. So the product rule says derivative of the first. Derivative of x squared is 2x times the second plus the first times the derivative of the second. Derivative of sine is, and that's all you can do. You can write it without the parentheses if you want, but nothing's going to go away. We don't have any like terms. So trig functions, this is one scenario where you will probably have to use the product rule if you have things multiplied together, because we can't multiply them and simplify it otherwise. All right, derivative of cosine. Do you want me to work it out for you like I did sine? Okay, we'll try it. So let's work out this derivative. So definition is the limit as h approaches 0. Cosine x plus h minus cosine x all over h. So we have to first start with this formula. I didn't have you write this one down at the beginning, but it's cosine of the first, cosine of the second, minus sine of the first, sine of the second. We still have our minus cosine x over h. Okay, we're going to take the same approach here. We see both of these have a cosine x in them, so we're going to put that together. So we'll do a cosine x, cosine h, minus cosine x over h, minus my other one was sine x, sine h over h. Then what can we do? Gotta cosine x. So then if we go to simplify, what's the limit as h approaches 0 of cosine h minus 1 over h?
0.
Minus sine x times, what's the limit as h approaches 0 of sine h over h?
1.
And we get negative sine x. So, from now on, you can accept this as fact. You will have to memorize the derivatives of these trig functions. So, the derivative of sine is cosine. Derivative of cosine is negative sine. The next slide, I gave you the derivative of tangent. If we wanted to prove that, we could just work it out using quotient rule. We know that tangent is sine over cosine. So if you did the quotient rule, that's low. D high, what's the derivative of sine? Cosine. Minus high. D low, what's the derivative of cosine? Over low squared. So then you get a cosine squared x plus a sine squared x over cosine squared x. What's cosine squared plus sine squared? And 1 over cosine squared would be secant. So you have to memorize the derivatives of sine and cosine. The others, if you forgot them, you could work it out with a quotient rule and get there. But it will be faster if you can maybe just make yourself some flashcards and memorize these derivatives. It would pay off in the long run, save you a lot of time along the way if you learned those derivatives. All right, so let's work out a few. So if I asked for the derivative of sine x over 1 plus cosine x. So what would I have to do here? Quotient. So that's low. D high, derivative of sine is cosine. Minus high. D low, derivative of 1 plus cosine x. Negative sine x. Over low squared. We start working this out. We distribute. We get cosine x plus cosine squared x minus negative, so plus sine squared x make sure you're not forgetting your denominators on these quotients. Then what would you do?
Sine squared.
Cosine squared plus sine squared is just 1. Anything else?
Go ahead and reduce the 1 over 5 questions.
Isn't cosine x plus 1 the same as 1 plus cosine x? So we could cancel one of those off top and bottom. So we get 1 over 1 plus cosine x. So make sure we simplify as much as we can. Questions there? Let's do one more example and then I'm going to stop for today. So I need the derivative for x equals cosine cubed t. Okay, what we have to realize is cosine cubed, this isn't just a polynomial. It's not just an x to the third. So you can't just bring down the 3 and subtract 1 from the power. What this means is cosine t times cosine t times cosine t. So we'll have to do the product rule here, but we have 3 pieces. Okay, product rule says you do one derivative at a time. So if I did the derivative of the first, derivative of cosine t is negative sine t. The other 2 stay the same. Plus, this time the first and last will stay the same. We do the derivative of the middle one. But the derivative of cosine t is negative sine t. Plus, this time the first and the second stay the same. We do the derivative of the last one. Derivative of cosine t is negative sine t. If we multiply, we get negative sine t cosine squared t plus negative sine t cosine squared t plus negative sine t cosine squared t. So those are all like terms, so what's my final answer? Set coefficients, negative 1 plus negative 1 plus negative 1 is negative 3. Sine t cosine squared t. So we have to realize if it's not just x to a power, if it's a function to a power, we have to write it out and do our product rule. So I am stopping here today. Homework wise,